Hi, today's topic, the convolution theorem. What is the definition of convolution? First of all, is that the convolution of two functions f of t and g of t is denoted by f of t star g of t and defined as f of t star g of t equal to integral 0 to t f of u g of t minus u du. So star denotes that there is a convolution between two functions f of t and g of t. Now what does the theorem state? Convolution theorem. The theorem states that if f of t and g of t are functions defined for t greater than or equal to 0, that is t being positive, then L of f of t star g of t equal to L of f of t into L of g of t. Now what is the proof? To prove this is that by the definition of a Laplace transform, L of f of t star g of t is equal to integral 0 to infinity e power minus st f of t g of t dt. So by definition of convolution that is star. So under the integral sign, star is defined. So we have integral 0 to infinity e power minus st integral 0 to t f of u g of t minus u dt du. That is equal to integral 0 to infinity integral 0 to t e power minus st f of u g of t minus u du dt. Now let us draw this as a region A. This is the region A, where A is the region represented as shown in the figure. So as I have showed it here. Now these integrals can be written as integral 0 to infinity f of u integral a e power minus st g of t minus u dt du. Now what does that integral a denote is that we have to substitute t minus u equal to v. If we put t minus u equal to v, t is equal to u plus v, and by differentiating we will get dt equal to dv. When t is equal to 0, v equal to 0, okay, and when t is equal to infinity, v is equal to infinity. So when t is 0, v is 0, t is infinity, v is infinity. Now as we proceed, L of f of t star g of t is equal to integral 0 to infinity f of u integral 0 to infinity e power minus of u plus v s. So we are grouping the terms here, e power minus st and e power, yes, t is substituted as u plus v and g of v dv into du. Now we have to separate the terms containing u and terms containing v. Thereby we will get integral 0 to infinity f of u e power minus us du integral 0 to infinity e power minus vs g of v dv. So this integral, the functions under the integral and the limits show that they are nothing but Laplace transform. It follows with the definition of Laplace transform. So integral 0 to infinity e power minus vs g of v dv into integral 0 to infinity e power minus us f of u du is what we have got. That gives us L of g of t into L of f of t. So not worrying about v and u, but that it is in the format of the Laplace transform. Hence we can write it as L of g of t into L of f of t, nothing but L of f of t into L of g of t. Hence the theorem. Now we know that the convolution f of t star g of t is equal to integral 0 to t f of u g of t minus u du. But here we can see that it can also be written as L of integral 0 to t that is the theorem, can be written as L of integral 0 to t f of t minus u g of u du. Not only that, we can write it as f of u g of t minus u du. It can also be written as f of t minus u g of u du. So based on the questions given, we can choose to write any one of these equations. And the corollary gives us an information about the inverse functions, that is L inverse f of s gs equal to f of t star g of t, that is equal to L inverse f of s star L inverse g of s, where f of s is equal to L of f of t, g of s is equal to L of g of t. Now let us verify the convolution theorem for the functions f of t equal to 1, g of t equal to sin t. Now, using convolution theorem, the theorem states that L of f of t star g of t is equal to L of f of t into L of g of t. Therefore, we need